Hello everyone and welcome to Network Playroom. Today we'll continue with the Advanced Spanning Tree Features video series. In this video we'll look at BPDU Guard. If you haven't seen part 1 already, I've covered port fast in the previous video. I'll leave a link in the description so you can go watch that if you like. But now let's get started with BPDU Guard. Now what is BPDU Guard and why do we use it? Quite simply, BPDU Guard prevents a port from receiving BPDUs. If the port still receives a BPDU, it is put in the error-disabled state as a protective measure. So why do we use such feature? What is the point of effectively shutting down, or more accurately making a port inoperational when it receives BPDUs? Well, consider the operation of the switched network. It is important that the active topology remains stable and predictable, meaning that you want to be sure that the network is not in a constant state of change, and you want to know where the root switch is located because that is the center of the spanning tree topology calculation. Everything depends on the root switch, essentially. Now imagine, for example, that you connect another switch which has a lower bridge ID than the current root switch. That will cause a new root switch to be elected and the spanning tree topology recalculated. And that will interrupt services on the network and reset the traffic paths. Now, BPDU Guard allows you to effectively enforce the spanning tree domain borders so that devices behind the ports that have BPDU Guard enabled are not able to influence the spanning tree topology. Because as soon as BPDUs are received on a port with BPDU Guard enabled, the port is put in the error-disabled mode and the violating device is blocked out of the network. So let me explain that again using the graph here. I'll actually create another layer so it's going to be easy to delete and we can move on with this video. So this is obviously a very simple network with 2 switches connected, but imagine this was something more complicated, and then you bring another switch here and connect it on S1 right here. So this one is a bad switch. We don't want this in the network doing anything. So pretend that this has a lower bridge ID than switch 1, which is currently the root. So this one, the new rogue switch, so let's just put rogue over here. It's gonna take over the root switch role from S1, and then it's gonna cause the entire switched network to recalculate the spanning tree topology, and it's gonna disrupt the services. But if we had BPDU Guard configured on this port, it's going to block this link as soon as this guy here sends BPDUs. So that's the magic of the BPDU Guard feature. Okay, now let me get rid of this layer so we can go back to the original state with only 2 switches. So much like the port fast feature, BPDU Guard has 2 configuration options. You can configure it globally using the spanning tree port fast BPDU Guard default command, or per interface using the spanning tree BPDU Guard enable command. So let me type those here so you can do it globally with the spanning tree port fast BPDU Guard and default. Quite a long command. And then you have the interface level command. And that is spanning tree BPDU Guard, BPDU Guard enable. Now, as you might guess from the command syntax, if configured globally, BPDU Guard is dependent on the operational state of port fast. It doesn't matter how port fast was configured, as long as it is enabled, BPDU Guard will be in effect. The per interface configuration command, on the other hand, unconditionally enables BPDU Guard on the port independent of the port fast state or access or trunk mode, actually. So now let's look at an example here. We'll refer to the simple diagram on screen. So there's two switches, S1 and S2, directly connected over one link, and it's connected to Ethernet 0/0 on both ends. So now let me refer to the document on the left-hand side here. Let's go over some command output and the configuration steps. So right now, switch 2 is configured in access mode. It's in static access mode both administratively and operationally. Now in the next command, if we look at the port fast status, you can see that it is disabled. So port fast is not configured on this interface on S2. And now over here, BPDU Guard is enabled globally using the spanning tree port fast BPDU Guard default command. And then we run the show spanning tree summary command, and it tells us that the BPDU Guard feature is enabled. So the BPDU Guard feature is enabled globally. And actually, viewing only this command output can easily lead to wrong conclusions, because you might expect the port to be error disabled after receiving BPDUs. However, after BPDUs are received, the port is still actually forwarding. So the port fast feature is not enabled, so the BPDU Guard never kicks in to error disable the port. And we can see that from the command output here in the next box. So the port is receiving BPDUs. You can see on this line right here. The port fast feature is disabled, as we've actually seen previously as well. So you can see here in the show spanning tree output that this port is still forwarding. Right here. So in other words, on S2, BPDU Guard was enabled global, but port fast was disabled. S1 was sending BPDUs, but because port fast was disabled, then BPDU Guard did not take effect, and that's why this port was not put into the error disabled mode. Okay, let me remove what I've just drawn on here. And since I didn't put it on a new layer, I'll have to erase it. Okay. So next, let's activate port fast globally on switch 1. And let's follow the guide here again. So switch 1, enable port fast globally with the spanning tree port fast default command. So now you see right here, if I can highlight this, that port fast is enabled globally and BPDU Guard is enabled globally. And actually, the BPDU Guard command is missing from this output. So it should have been right here under the spanning tree port fast default command. There should have been spanning tree port fast BPDU Guard default, the same command that was configured on switch 2 earlier. So now we can see on switch 1 that BPDU Guard, port fast is enabled. And right here, we're making sure that the interface is forwarding. Okay. And why is that? So why is the Ethernet 0/0 interface still forwarding even after we enabled the port fast feature and the BPDU Guard feature is in effect? Why are there no log messages? Nothing. And this is very important to understand. The answer lies in normal spanning tree operation. So these switches are running PVST plus, and only the root switch sends out BPDUs every hello interval unless there is a topology change. Now, because S1 is the root switch and no events have occurred that would trigger S2 to send a topology change notification, then switch 1 has not received any BPDUs. So if we scroll down a little bit here, you will see that in this command output right here. So you see that no BPDUs have been received from S2. So again, if I backtrack what we've done here, so BPDU Guard was enabled globally, as well as port fast globally. So that enabled those features on this interface right here. But the port was not put into the error-disabled state because it was not receiving BPDUs from S2. So there were no incoming BPDUs on this interface, which is why it didn't go into the error-disabled state. And this is because of normal STP operation. So under normal circumstances, S2 would not send BPDUs towards S1. Okay, let me get rid of this as well. So we'll go back to the original state again. Okay. So now if we run those same commands on S2, let's see what happens. So spanning tree port fast is enabled globally on S2, and remember that the BPDU Guard is already enabled globally. So this immediately triggers these log messages that state that received BPDU on port Ethernet 0/0 with BPDU Guard enabled, disabling port. Right here. And now if we check with the show interface status error disabled command, you can see that this port is in the error disabled state. So let's backtrack quickly again. So BPDU Guard was already enabled globally, and then port fast was enabled globally. So now both port fast and BPDU Guard features are enabled on this port right here. And when S1 sends the next BPDU to S2, it'll be put into the error disabled state. Error disabled. Now there are two ways to recover an error disabled port, either by manually re-enabling with the shutdown and no shutdown commands, or by configuring automatic error-disable recovery with the error-disable recovery cause BPDU Guard command. The default recovery interval is 300 seconds, but that can be changed with the error-disable recovery interval seconds command. So to recover this port from the state, you can do either shutdown followed by no shutdown, or you can do the automatic recovery. So let's look at that quickly on the document here. So here you can see that the error-disable recovery is enabled for BPDU Guard. The default timer is 300 seconds. But note here that obviously automatic recovery does not fix the root cause. So after 300 seconds, the port would be re-enabled only for a short period of time before being error-disabled again when the next BPDU from the root switch, in this case S1, is received. Okay, let me get rid of some of the text again. Okay. Remove all of this. All right. Now let's quickly prove that the interface level BPDU Guard configuration command is indeed independent of the operational port fast state or access/trunk mode. So we'll go on S2 and then remove these commands. So port fast is no longer enabled globally, nor is BPDU Guard. So instead, BPDU Guard is configured on the interface, which is independent of the port fast state. So we can verify that on here. It says that the port fast feature is disabled. And now if we look right here, you can see that the BPDU Guard feature is still enabled. And if we look at the next block of code, you can see again, once BPDUs are received, the port is put into the error-disabled mode again. And that can also be verified with this command, show interface status error-disabled. So again, what happened is BPDU Guard was configured on the interface. So let's just write int for interface. And as soon as S1 sent BPDUs, this port was put into the error-disabled state again. As a summary, here are the most important takeaways from this video. Number 1, BPDU Guard prevents a port from receiving BPDUs. If a BPDU is received, the port is put in the error-disabled state. Number 2, there are 2 ways to configure BPDU Guard, globally and per interface. Number 3, the BPDU Guard global mode is dependent on operational port fast state. Let me actually write that down. BPDU Guard global is dependent on port fast. Then number 4, BPDU Guard interface mode is independent and unconditional. Let's write that down as well. BPDU Guard interface is independent and unconditional. So it has no relationship to port fast. And finally, number 5, remember the normal operation of STP when BPDUs are sent and not sent. I'll write that down as well. Normal operation of STP when BPDUs are sent and typing something else here and not sent. Note. This is very important to understand, as we've seen in the example. So you might have thought that BPDU Guard would have disabled the port, and it should have and would have if it had received BPDUs from the other switch. But because of normal STP operation, no BPDUs were received. So make sure to pay attention to that. So that concludes this video. Hopefully this video explained BPDU Guard in a sufficient level. We'll talk about BPDU filter in the next video. Until then, have a great day, and I'll see you next time.